Hello everyone, welcome to this session. In the next 5 minutes, I'll walk you through our proposed system Refiner. Refiner is a federated learning system that features reliability and auditability, and it provides incentive mechanisms for promoting cooperation among the participants. Refiner involves three kinds of participants: the requester who publishes federated learning tasks, the worker who performs local updates to the model, and the validator who evaluates the quality of the local model updates and aggregates them. Let's start from creating a new task. Refiner provides a group of customization items for the requester to set up a task, including worker and validator number, round number, rewards per round, and so on. We set up the task in manual mode to explicitly demonstrate each step. 4 sub-panels are available to the requester to monitor and manage his task, including a member panel, a budget panel, a progress panel, and a performance panel. To get the task started, the requester needs to recruit members for the task. Switch to the workers page and we can see the task just published by the requester with all kinds of details. We'll let the worker join in the task by clicking the button. Meanwhile, another 2 workers which are running in the backend are also enrolled. The validators are randomly chosen by a committee selection algorithm. Back to the requester's page. The requester needs to refill the task by transferring a certain amount of Ether to the task contract to be used as rewards paid to other participants. The budget panel shows the usage of Ether so far. The requester needs to provide a starting global model and the validation dataset. Now click the Start button and the round is started. Go to the workers page and we can see that the status of the task shows training. The expanded panel allows the worker to perform his job in 3 steps. Firstly, the worker retrieves the hash value of the starting model from the task contract and downloads the model from IPFS. In the second step, the worker performs local updates to the global model based on his local training data. We prepare both a normal dataset and a bad dataset with shuffle labels. The bad dataset will be used by one of the back-end workers. After the local training finishes, the worker uploads the model updates to IPFS and submits its hash value to the task contract. Now we switch to the validators page. We can see that the status of the task shows evaluating. The validator performs her job in 3 steps as well. Firstly, she retrieves the validation dataset and all workers' local model updates. Then, she evaluates the performance of each local model and aggregates qualified ones into a global model. Before submission, she can preview the results to be submitted. We have another 2 validators running in the backend, and one of them submits fabricated results. Now we go back to the requester. The requester can click the lock button to retrieve the results. The time consumption panel provides information including the total time consumption, average time consumption per round, and detailed time usage in different steps of the latest round. The worker summary panel shows the score, the status, and the rewards of each worker. The local model update with 0 contribution is rejected and the corresponding worker receives no reward. Likewise, the validator who submits inconsistent validation results is not rewarded. The model output panel shows the hash values of valid local model updates and the aggregated global model, as well as its performance. The requester can download the aggregated model, which can be used as the starting model of the next round. And this is the workflow of running a federated learning task with Refiner. Thank you so much for watching.